Hello everyone. Today we are going to start with the topic binary search. And this is one such topic which is asked in almost every interview round, in every coding round. And it is easier to crack the questions of this type since it is easy to identify this question. So let's start. First of all, why binary search? Like हम क्यों binary search यूज करें? हमें तो एक और भी सर्च आता है, लीनियर सर्च भी आता है. हम जब भी सर्च बोलते हैं we speak of word search. What comes in mind? Let's take like for example the array is 14723. We start with we will initialize our starting element with this. We will iterate over the entire array and check if the required array is found or not. This is the thing we do. But let's suppose the array is sorted. Let's suppose array is something like 1, 4, 7, 9, 11. And now you are told to find if whether 9 is present in this array or not. So if you do not know the concept behind binary search, what you will do? You will start from 1. You will check that yes, whether 1 is equal to 9 or not. No, you will move to 4. You will check if 4 is equals to 9 or not. Okay, you find that no, it is not equal. You will move to 7. Then you will check whether 7 is equals to 9 or not. Okay, not equal. Then you will check whether 9 is equals to 9 or not. Yes, it is equal. And you will return this index 3. But tell me one thing, if you know that your answer lies in this part or this part of the array, like if you divide the array into half, and you know that whether your answer lies in this part or this part of the array, wouldn't it be easier for you? Or wouldn't the time taken to do the search will decrease exponentially? The answer is yes, it will decrease. Like, for example, when I told you to find out the element 9, what you will do is you will divide the array in two halves. This will be the middle element, and you will check whether this element is greater than or less than the element which you need to find out. For example, in this case, 9 was greater than 7. So you know that your answer will not lie in the left part, right? Left part में तो नहीं हो सकता ना, because 7 is 7 is less than 9. So and the array is shorted. So all the elements to the left of 7 are less than 7. So that your answer will definitely lie in the right part of the array. So you will search in this half part. Now again you will divide the array into two parts. This will come out to be your middle element. Now you will check that your target element is either equal, less, or greater than the required element. Like the element present at this index. You will get that yes, it is equal. So you will return the index of this position. So how many iterations did we did? We did 2 iterations. First of all, we came at 7 and then we came at 9. So before that, when we were doing linear search, we did 4 operations. Now this is array of size 5. We have array of size like something around 10 power 9. So in case of linear search, we would be doing around 10 power 9 iterations in the worst case. Similarly, if you apply binary search, we can reduce the time. We will see how much time we can reduce, but yes, we will be able to reduce the time to a great extent. Now let's see how we approach with questions of binary search. Suppose there is an array like this 1, 2, 3, 4, 7, and 9. And suppose you need to find whether an element like 5 is present in this array or not. Okay. So what you will do is, first of all, you will initialize your starting index and ending index. Your answer will always lie within those indexes. So suppose this is the starting index and this is the ending index. Your answer will always lie, your answer will always lie within starting index and ending index. So this is the thing which is very important. When we level up the questions, you will find that, okay, this is very tricky, like how we will initialize starting index, how we will initialize ending index. So that should be fit in the mind, like your answer will always lie within those starting index and ending index. Now you will find out the mid. How will you find out the mid? Many people tend to write mid as starting index plus ending index by 2. But it will be better if you try to avoid this. Why? See, let's suppose starting index is equals to the maximum integer possible, that is int max, and ending index is also equal to the maximum integer possible, which is int max. So when you do starting index plus ending index, it will result into 2 multiplied by int max, which will definitely go out of bounds. Like integer can't store like this value, right? So it will go out of bounds. So to avoid this, what we can do is we can find out our mid like this. Mid is equals to starting index plus ending index minus starting index divided by 2. So by doing this, what benefit we will get? We can avoid integer or so we will find out our mid with this. Now once we find out the mid, once we found out that okay, we found out some value of mid. Let's suppose in this case the starting index is equals to 0, ending index is equals to 5, and if we calculate the mid by our formula, we will get 0 plus 5 minus 0 divided by 2, which is nothing but 2. So this is our middle element, right? Now, once if we are asked to find whether a particular element is present at the, in this array or not, what we will do is there are 3 cases possible. Case 1 is whether the element present at mid is equal to the target element, or the element present at mid is greater than the target element, else the element present at mid is less than the target element. These are the only 3 cases possible. Now let's suppose this is the case. Like the element present at mid is equals to target. In that case, you will simply return mid, like you found out the element. If the element present at mid is greater than the target, so what you will do? You will simply say that okay, the element which we are trying to find out is actually less than what we encountered now. So the answer lies in the left part. So what you will do is you will shift your ending index to mid minus 1. And in the other case, if you found out that the target element which you are targeting is is greater than what we encountered just now, this means that if the element is present in the array, it must be present in the right side of the array. So you will shift your starting index to mid plus 1. You will run this, and if till the end you did not encounter the element, you can simply say that okay, the element is not present in the given array. So this is a simple thing. This is the most basic code of binary search. We will code it down, but like this is the concept which we use. We shift ending index and starting index depending upon the conditions. And we calculate mid by this by so that there is no integer overflow. And yes, so this is the thing which we do. Let's code it down once, and then we will see the time complexity. टाइम भी तो बचना चाहिए, लाइक अगर टाइम ही नहीं बच रहा तो लीनियर सर्च ही कर लो ना, क्यों इसको करना, है ना? So we will see that how much the time gets reduced, but first let's code it down. Let's take this input vector like array. Okay. So this array must be sorted in increasing or decreasing order. For now, we are assuming that we are taking input for the array sorted in increasing order. Now let's suppose we take an input of the element which we need to find out in the array. Now let's initialize our starting and ending index. Starting index is the minimum possible value. We need to find out the index at which that particular element occurs. So the index will be minimum possible index is 0 and maximum possible index if the value is present in the array is n minus 1 because the elements lie between 0 and n minus 1. Okay, so now we will run our while loop. We will find out the mid. Then we will see if the element present at that particular index is equals to the target element. If that is the case, we will print that index and return from here. Like our job is done. If this is not the case, there are two cases possible. The element present at the mid is greater than the target element. If this is the case, then definitely our answer lies in the left part of the array. So we will shift our ending index. And if opposite is the case, then our element definitely lies in the right part of the array. So we shift our starting index. Once we come out of this loop and we have not returned till now, this means that we cannot find the element in the array. So we will simply print that element not found. So let's run this code once, like let the array be of size 5, array be this, and let's find out the element 7 in the array, which is not present. So our answer should be that the element not found. Okay, so it is doing great wonders. Let's suppose we need to find out element 8, which is present in the array, right? So we should get the position 3. Okay, so you can see over here, we got our required answer. So this is what we do in binary search. This is the most basic code, most simple code. We will only level up from here, but the things will remain the same. Like you are going to initialize your starting and ending index. You are going to shift your starting and ending index based on the condition, and then you are going to return the answer. Now let's first see the time taken by this code. Like what was the time taken when you were doing linear search? You were traversing over the entire array. The time taken was big O of n, right? So if the value of n is around 10 power 5, so number of iterations in the worst case which you will be doing is 10 power 5 iterations. Now let's see how many iterations in the worst case we are doing in the case of binary search. Let's suppose we denote T of n is the time complexity of our following code. So what we are doing is we are dividing our arrays of size n into array of size n by 2 and doing some constant operations, right? That is the thing we are doing now. We have an array, we are dividing it into half part. We are doing some constant operations like we are checking that if mid is equal to target, if mid is greater than target, mid is less than target. These all operations are constant operations, right? We can do it in a constant amount of time. So big of 1 is a constant amount of time. Plus, if like suppose mid is not equal to target, mid is either greater or less than the target. So we will now do the operation in half part of the array. So the time complexity T of n comes down to T of n by 2. That is the time taken to do the traversing the half part of the array plus some constant operation. Similarly, if we write this recursive relation, we can write T of n by 2 is nothing but T of n by 4 plus some constant operations. T of n by 4 is equals to T of n by 8 plus some constant operation, and so on. At the end, let's suppose we divided our array by, we keep on dividing, and at the end, let we divided it x times. So while dividing with x times, let's suppose we encounter a single element. We can't divide, we will not be dividing it infinite amount of times, right? Like अगर एक array है, इसमें 1 2 3 4 5 6 7 कितने भी एलिमेंट्स हैं, आप इसको अगर एक एक करके डिवाइड करते जाओगे हाफ हाफ पार्ट्स में, ऐसा तो नहीं है कि आप पूरी जिंदगी डिवाइड करते ही रहोगे। आप कभी ना कभी ऐसा समय आएगा जब आपके पास एक सिंगल एलिमेंट होगा, एंड लाइक यू आर नॉट गोइंग टू डिवाइड दिस एलिमेंट, राइट? ऐसा तो नहीं कि आप एलिमेंट को आधा पीस से काट दो, आप ये तो नहीं कर रहे थे। वी वर डिवाइडिंग द इंडेक्सेस लाइक द पोजीशंस। So at some point of time, we will realize that we have come down to a single element and we can't divide the array from here. उस समय, at that point of time, you need to make the decision, right? What you will do. You will take that or not take that. You will return true, false. That is the last time you can take the decision. So if I say that I come down to a single element, so can I write that n divided by 2 power x will be a single element? We started with n elements, right? Now we have come down to a single element. So n divided by 2 power x will be 1. So we can write from here that 2 power x is equals to n. And from here, we can write that x is equals to log n base 2. Simple logarithmic property. So now, if we sum up this all, like if we sum this, this, up to this, if we sum up this all, then we can see that this and this gets cancelled. This and this gets cancelled. This and this gets cancelled, and so on. This and this will get cancelled. And we will be left out with T of n is equals to big O of 1 plus big O of 1 plus dot dot up to x times, right? Or if you notice like nicely, it will be x plus 1 times. Or you can simply take x times also, it will not affect your answer. But more precisely, if we say, so we can say it will be x plus 1 times. So if you sum up this all, you can write T of n is equals to x plus 1 multiplied by some constant time. Now the value of x is log n base 2. So it is simply log n base 2 plus 1 into some constant time, which you can say as like this is equals to equivalent to log n base 2. So we have come down like from big O of n to big O of log n base 2. Right? So let's see how many iterations we reduced. If let's suppose array was of size 10 power 5. So in case of linear search, the number of iterations at max which we will be doing will be 10 power 5. In case of binary search, the number of iterations we will be doing is log n base 2, which will be log 10 power 5 base 2, which will be something around 20 or 21. Let's suppose 20. So see, over here we were doing 10 power 5 iterations. Over here we are doing only 20 iterations. So that's the difference. Huge difference, I must say. But what is the condition? The condition is that the array must be sorted. Array must be sorted. If array is sorted, then yes, you can apply binary search. You can do wonders. You can reduce time to a great extent. But if the array is not sorted, if you can sort it and apply the operations, okay, fine. But if you can't sort it, the time does not allows you to sort it. So look on some like different approach by which we can solve the question. So yes, binary search, like we will be saving the time to a great extent. So in this playlist, what we are going is, the topics which we will master is learn the concept behind binary search, which we already did. We will see that how the time reduces, which we already saw. And we did a simple problem on binary search, right? Now we will learn some inbuilt functions. We will learn precedented binary search, do a sample problem. We'll learn to identify questions of binary search. Okay. So this is the most important part. Like questions देख के कैसे समझे कि ये binary search का question. The question will not write you and give like, okay, I will be solved by binary search. No, you need to think on it, and there are some tricks like by which you can identify that this question can be solved by binary search. I am going to discuss with you all that approach, and we are going to practice some really good problems, like which will open up your mind to a great extent, will give you tools to approach the concept or the problem. And yes, in this video we will keep it till here, and let's meet you in the next video. Thank you.